the wave particle property. Aajke we'll look into the math of this. Okay, the math is important for us. So let's have a look here. So before I start, I just want to give you a reminder. What is this thing? It's called the photoelectric effect. It's essentially an experiment. And in this experiment, we found that if you use red color light and you shine this red color light onto this surface here, right? You find that what does light bring in with it if it's shown onto a metal? Energy, right? And we thought that the energy can be useful in removing electrons from the metal, but we found it didn't really work. Why? We used red color light of 100 watt intensity, right? We moved on to 400 watt per meter square intensity, still nothing happened. And then we went to like really high power, nothing happens, right? Which seems odd because you're still providing energy. It's not like you have stopped providing energy. And the energy you're providing is quite intense, right? Because the intensity is very high, yet no emission takes place, which kind of defies the laws of waves. Is according to wave theory, right? The more the intensity, the more the energy. On top of that, there's something else that waves do. It's called the build-up process, where if you keep beaming the wave at one place for a long time, that place will actually gain a lot of energy. It's like, for example, if you hold like a magnifying glass under the sun, right? It'll make a hole somewhere because it builds up. So there's a build-up out there, there's high intensity out there. So essentially the energy is surplus. That's what's happening, right? Yet we do not see any emission take place. However, it is found that if you change the color, right, emission starts happening. And when you change the color, the emission happens regardless of the intensity. When for some reason, the amount of energy, the amount of power is not a factor. What becomes a factor? Color. This idea that the color is a factor contradicts what theory? Wave theory. Because according to wave theory, color has no role to play. What has role to play? The power of your lamp. So 100 watt red light and 100 watt blue light will give you how much power? 100 watts, same, nothing different, right? But for whatever reason, the red did not cause any kind of emission at all. But the blue one does give you emission at any power. So that was a little baffling, right? And then eventually they started wondering, like, why is color, right, frequency a factor? And that's when they realized that there was an equation out there, proposed, never proven, that the energy of a light can depend on frequency. But you have to do, or you have to make a exception here. What is it? You have to consider light to be a what? Particle. And this is the first time we found evidence that light, which is always supposed to be a wave, can also show what behavior? Particle behavior. And that's the whole idea of wave particle duality. Wave particle duality tells you that particles can, under certain conditions, show what behavior? Wave behavior. And waves, under certain conditions, can show what behavior? Particle behavior. When does a particle show wave behavior? When a particle interacts with a gap that is similar to its what wavelength? De Broglie wavelength. So I think we discussed this, that if everyone has a wavelength, but if you come across a gap that's close to your wavelength, right, you will diffract. That's for particle becoming wave. What about waves becoming particle? Turns out there's only one instance that we know. A wave will behave as a particle only when it interacts with what? An electron. Okay, and that's what's happening here. So there are other places in our syllabus where we'll see, wave interaction with electron, and we will see that it does behave as a particle out there. So the idea that a wave can become a particle has to do with the electron interaction, and this is one of the better evidences of it out there. So yeah, this is what we saw. এখানে এটা আবার explain করব. Right, so this was, what would happen if it was a wave? What happens if it's a particle? Okay, so this is something that we saw earlier. I want to do photoelectric effect only because that's our chapter. Okay, so let's try to understand the photoelectric effect in terms of math. So then I'll bring all them together. Okay, there's only one equation in this chapter, one overall equation. So if possible, go to this page where it says the photon, and I'll explain how this thing works. So our main aim is to solve the photoelectric effect calculation. Okay, so let's first try to understand everything about the photon. What is the photon? How does it behave? What do we need to know about it? So everything and anything about the photon. And then we'll go to the photoelectric effect. Okay, so what's a photon? Definition of photon, it's a very common definition out there. Photon hoche, I'll give the definition later in full, but it is basically a packet of fixed energy of electromagnetic wave. This is what a photon is. A photon is a packet of fixed energy. So packet, it had 2 marks here at definition. Packet, fixed energy, electromagnetic wave, right? So photon can be generated by anything from the electromagnetic spectrum. You have your electromagnetic spectrum. So anything in the electromagnetic spectrum can generate a photon. Okay. So yeah, that is some of the basic background we need to know for a photon. So the first question is, what is it actually? What is a photon? So photon, it's still not well understood, but what we know so far is that photon is actually just a packet of energy. The reason why we call it a packet of energy is because each photon packs in how much energy, the exact amount. Change. So if you have a photon, the amount of energy that this photon has, this packet has, if you want to find the energy, the formula is E equals to HF. So when you have a light source, right, and light source take a light bear, that doesn't change the fact that you're getting light because it's a photon. So how does this thing work? So you have a light source here, blue light, and it can take 2 things can happen. Either what can come out from this? Wave. Or what else can come out from this? Particles. Okay, so these are things that can come out from this source here. That's a particle out there. A photon. Can you remind me, when does it produce a photon and when does it produce a wave? Yeah, so when it interacts with a metal here, so let's say you have a metal here, it'll behave as a photon. And if it's not a metal, it'll behave as normal particles out there. But the thing is, this is a 100-watt light source. What does it mean by a 100-watt light source? So if you have a light source that's 100 watt, right, what does that mean? Every second, this light source is producing how much energy? 100 watts, right? Now, if it's producing 100 watts in terms of wave, then you use wave equations and wave properties to explain this. But if it's producing 100 watts using photon, it can it. So the idea is that all these photons that are coming out every second, if you take all their energy together and if you add them, how much will you get? 100. Same. Okay, so that's the difference, because I find students have this confusion that they feel like, oh wait, light এখন photon হয়ে গেছে, energy ঠিক মতন দিচ্ছে না, or it's not behaving like the light. It is doing exactly the same thing. In fact, a moment from this light, right, there could be photons coming out. You wouldn't know any difference. Why? It's still giving you energy. It still behaves as like light. It's just that typically light will have what properties? Wave properties. Wave properties V equals to F lambda and other equations of waves that you have learned, right? So in this case, you can use V equals to F lambda to describe everything. But when it comes to a photon, V equals to F lambda কাজ করে না. And that's why we have a new equation that we need to look into. The equation is this: E equals to Hs. E is the energy of a single photon. Energy of a photon. H is a Planck constant. At one point memorize better because only Q's করতে হয়. And F, this is the missing piece of the puzzle, is your what of the light source? Frequency, right? This is where it makes no sense to most people. Why? I'm talking about a particle here. A particle happens to have a what here? Frequency. So that's what Einstein actually came up with a solution with, but as an idea. He said that, yes, there's frequency out there, but that frequency dictates how much energy will be there. So this photon doesn't actually have a frequency. When according to Einstein, photons are what is particles. Just imagine I'm throwing marbles at something. Marble what photons are. They're not vibrating or anything. But the energy that each photon contains, right, depends on the watt of the wave it was from, the frequency. So the higher the frequency, the more what would this thing have? Energy. And this is the energy of a photon equals to Hf. Now, what to do with this information? So তোমাদের কি জিজ্ঞেস করতে পারে? So there are a couple of questions I'll ask you. The most basic one is this. find the energy of a single photon. Energy of a single photon of red light. What's the wavelength of red light? Last question, I think you guys told me 700 nanometer. Okay, so this is the most basic question you can get. Follow-up at the question, which is advanced. So there's no middle ground here. It's very basic or it's quite advanced. Question find the number of photons released from a 100-watt lamp. A same red light যেটা ওটা যদি হচ্ছে 100 watt হয় কয়টা photons বের হবে ওটা বের করতে হবে. So how do we do these two math? এই দুটো math পারলে we can move on to the next part. Okay, মানে আজকে আমাদের main aim হচ্ছে photoelectric effect পুরোটা breakdown করা. Photoelectric effect equation has three parts: the photon energy, the work function, the extra KE. এই তিনটাকে একসাথে কানেক্ট করতে পারলে এই চ্যাপ্টারটা আসে একসাথে. Okay, so first I have to teach you everything about the photon energy, and then I'll teach you about the work function, ওটা একটা property, and then the extra KE বলে একটা জিনিস থাকে. And once you put them all in an equation, is basically the chapter. Okay, so let's try to figure out number one and answer. What is the energy of a single photon? So formula কি হবে? E equals to hf, right? But একটা shortcut ঠিক না, একটা alternate তোমাদেরকে দেখো এখন. তোমাদের সিলেবাসে ফ্রিকোয়েন্সি মোটামুটি কোনো সময় দেয় না for a light source. ওরা সবসময় কি প্রোভাইড করে? Wavelength, right? So তার জন্য there's an alternate equation here. E equals to hc by lambda. মানে তোমরা directly এটা ইউজ করতে পারো. And যারা wonder করতেছে how do we get this c by lambda? V equals to v equals to f lambda. So f equals to v by lambda. And since we are dealing with light, what is the value for speed? C, right? So এটা directly use করা I think is easier. In fact, একটা পয়েন্টে students ওইটাই মনে রাখে, which is not bad. So hc by lambda, h is 6.63 into 10 to the power minus 34 into c হচ্ছে speed of light, 3 into 10 to the power 8, divided by lambda is 700 nanometers. So 700 into 10 to the power minus 9. Care to check করে দেবা কত আসে? And then there's this change we need to make. We change to তোমাদেরকে শিখাবো এখন. So কত আসে আগে দেখি. So this is the energy of one single photon from a light source. Okay, it's supposed to be very small. Into 10 to the power minus 19. Yes, 2.84 into 10 to the power minus 19 joules. Now I think you can already notice the value is very small. So to deal with such small values, we have a conversion method. Jeta ASA I mentioned, but A2 it's like mandatory. You need to convert this to something called the electron volt. Okay, so electron volt conversion and it's one of the easiest conversions out there. Yes, so to convert from joule to EV, by the way, electron volt is still a unit for what? Energy. So joule to EV যদি convert করতে চাও, you need to divide whatever number you have with the charge of an electron. That's it. Okay, so joule to EV conversion is divided by the charge of electron, and of course reverse কি হবে multiply করতে হবে. Okay, so if I want to convert my joule to EV, I will divide this number by that, right? So এখানে যদি convert করতে হয়, what should that be? 2.84 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. Question হচ্ছে, why do we do this? You'll see right now. করে দেখো কত আসে. 1.77. 1.775. Okay, so 1.76 EV. এটা কেন করি আমরা? Isn't 1.76 much more easier to work with? Because আমাদের একটা পয়েন্টে compare করতে হবে অনেক. And when I'm comparing 2.84 into 10 to the power minus 19, বারবার এত কিছু লেখা is tedious. So 2.84 into minus 10 to the power minus 19k, we convert into this. This is still a unit for energy. It's just much more, user friendly. Okay, so আমাদের যেটা করতে হবে is like we need to convert into this unit and work with it. However, there's a catch, a very unfortunate catch. When you do your math, you have to bring back to what? Joules. EV is not a SI unit. So, if I'm doing like, I want to find the KE, right? Half mv square. So the KE can't be in this unit. It has to be back in what again? Joules. So always remember that they will provide you data in this, but to do math, you must always keep your answer in what? Joules. Okay. So I hope you understand that if you want to go back from EV to joules, what do you need to do? Multiply. Okay. So that's there. Right, so একটু কি বুঝছো তোমরা? How do you find the energy of one single photon? Okay, let's move to the next one. Eta, I want you to give a thought. Find the number of photons released from a 100-watt lamp. So I have this 100-watt lamp here, red color light বের হচ্ছে. How many photons will be released from this lamp? এই যে এখান থেকে photons বের হচ্ছে. You need to tell me how many photons will be released by this lamp. একটা time frame দিয়ে দিচ্ছি in 1 second. Find the number of photons released in 1 second. Find the number of photons released from a 100-watt lamp in 1 second. Yeah. So it's a 100-watt lamp, right? What does that mean? Every second, how much energy does it provide you? 100 joules. So if one photon of red light is capable of giving you 2.84 into 10 to the power minus 19 joules, how many photons will give you, how much is the energy that eventually comes out? 100, right? So therefore, this lamp will give you, 5, it's going to be a very large number. 4, 10 to the power 20 something after that. 3.52 into 10 to the power 20 photons. So it's কিন্তু খুবই important background here. Okay, the background here is that আমাদের যখনই হচ্ছিল কোনো photon দিবে, there are two things we need to learn for a photon. What are the two things we need to learn for a photon? How much energy it has and how many photons are released from a source. So to find the amount of energy in a single photon, what's the equation? E equals to hf. Okay, and if you want to find the amount or number of photons released from a source, you do this unitary method out there. Are you with me so far? Achha, okay, let's move on to the next one. So photon e kono question theke amra bolo before I move on. There is a formula for the photon momentum. We'll do that later on for data set related na, but photon theke this is all you need to know. And a photon is a packet of energy. Definition tomre jigesh koro, I'll give you a proper definition later on. It's a packet of fixed energy of what radiation? Electromagnetic radiation. Okay, so sound wouldn't create a photon, obviously, right? But ultraviolet, X-rays, they do produce photons. And when do you see a photon? Typically, when it interacts with what? Metals. Okay, so whenever it interacts with a metal, you'll see that it becomes a photon. That no one knows so far. One idea out there is that the electron is very easy to interact with the photon because it has this property. It's called a lepton. Do you know what a lepton is? We had it in AS. Okay, so electron, neutrino, muon, neutrino. So it's something to do with that. The strong nuclear force particles, like your quarks, they don't do anything. So something to do with the electron property, most likely. But yeah, it's still not. There are a lot of ideas out there, so we don't know. So there's this thing in physics called the very famous phrase, collapse of the wave function. Like a wave collapses and it doesn't become a wave, it becomes a particle. There are few things out there just mysteriously makes the wave collapse. One of them is the electron. All right, let's move on. So next, this is the photon. Okay, so it's a packet of energy. Oi fixed jagay tumre syllabus they prefer the word discrete. Say what term our future use for. Do you know what discrete means? Specific values. It's a continuous versus discrete. What's a continuous example of information? Light, height. Yeah, height, weight. Right. These can be any number out there. Right. But discrete hoche fixed values. So for example, chairs. Chairs are discrete values. Right. They can't be any number. They have to be just whole numbers. Right. So you can the amount of energy that photons have from a light source. They're always what value? Fixed value. They can't be like a continuous range of value out there. Okay, so let's move on to the next one. So the next one is the effect itself. So later, we will go through the whole process. So listen carefully. If you haven't understood the topic yet, it doesn't really make a big difference. This is what matters. Eta jodi paro, you should be able to solve, I think, 80% of the question. What I'm going to show you right now. Okay, so let's say we have a metal surface here, and the metal surface has electrons in it. These electrons are your delocalized electrons, you could say. Basically, they're very easy to remove because they're not bound very strongly with the nucleus. Unlike what? Non-metals. Non-metals electrons are, not free to move, right? So these electrons are delocalized. They're readily available out there. And to remove electrons, what do you need to provide them? Energy. So we have heard about this before, right? So electrons require energy to be removed. এখন আমরা কি দিয়ে এনার্জি দেওয়ার চেষ্টা করতেছি? What is our source? Light. Okay. There are other ways of giving energy. Let's discuss them. I could provide these electrons what here? Heat. And if I provide the electrons heat here, at a point the electrons will gain enough energy that they can escape. It's like forcing the electrons to evaporate. Remember evaporation, when highly energetic particles escape from the surface because they have excess heat, right? So you can actually do this. And that kind of emission is known as the thermionic emission. We will see that in medical physics, okay? X-ray machine use kora hoy. So thermionic emission is the process where heat can be used to remove electrons. And this is proven. And this was proven very well before the experiment we're going to do right now. Arcta way exists for it through friction. Heat, which is, if I rub it against my hand like this right now, I'm actually removing electrons from here. Thermal energy. So it's the kinetic energy of other particles colliding with them and giving them energy. So it's the molecular, so the vibrations are taking place. Those vibrations give energy to the electrons out there. The other one is your friction. So friction থেকে কেমনে energy release হয়? So when you're rubbing two surfaces, surface কি করে? Heat করে. কেন heat করে? You're at the end of your school level physics, right? এগুলো সব পারা উচিত তোমাদের. Why does a surface heat up when you rub it against anything? Friction, right? But why does friction cause heat? Yeah, I mean, that's true, but why does it cause heating? Huh? Yes. Work is done against. Yeah. So what's happening is you're all collectively right. When words takes for lenses law. So basically, what happens is when you rub against two surfaces, the surfaces are rough. That's what friction comes from. And rough surfaces, when they collide with each other, they experience what? Work done against that value, right? So the energy you are giving is converted to what energy there? Internal energy. So as a consequence, the thing starts to heat up. And some of this heat will go to the inner layer, and those inner layer electrons can take the heat and then what? Escape. That's what friction is, right? So we thought, why not light? Light should be fine, right? So that's where the experiment comes from. And আমরা যেটা করছি এখানে আমরা red light দিয়ে start করি, and we'll try to explain all the behavior we have seen earlier. So আমরা red light use করলাম এখানে, and red light use করে we will try to emit electrons from the surface. I'll change the color here. Right. So red light থেকে কি বের হবে? There are two things that can come out from the red light. It's either a wave or a particle or a photon, right? But the thing is, আমরা ধরো already জানি যে wave বের হচ্ছে না, photon বের হচ্ছে, কারণ wave হবেই না। তো কেন? A wave doesn't interact with what? An electron. It has to be a what that interacts with an electron, a photon. So let's assume it's a photon. এটা এরকম না যে photon হলে emission হয়. We have seen that, right? So কেন emission হচ্ছে না? So it turns out when you have red photons coming out from here, each single photon contains what? Energy, right? How would you find that energy? Can you E equals to HF, okay? So J photon or energy acionic, and they're all coming out from different places, and they're going to go and collide with every electron out there. What happens when they collide with the electrons out there? Let's try to see this. So if the photon here goes and interacts with an electron here, this photon will interact with this electron only, and no other photon at that moment can interact with this electron. It can't do a one-to-many interaction. It has to be a what interaction? One-to-one. It's a very important feature of photoelectric effect that one photon will exclusively interact with one electron at a time. Etar energy ta ekhane ashlo. Now, unfortunately, the problem is this photon that you see here, as an example, only contains 10 joules of energy. Acha egulo kintu banano number, okay? 10 joules. And my electron requires 15 joules to come out from this metal. Do you think this photon, right, can provide the desired energy? No, তার জন্য emission হয় না. However, a student may argue, why not another photon comes in and gives it energy, and now the energy is 20 joules, right? ওটা কেন কাজ করে না? Because stacking হয় না. Stacking মানে কি build up হয় না. So the question is, যে energy টা আসলে ওটা কই গেল? So the energy comes here and the electron doesn't use the energy. The energy is dissipated to the surrounding as internal energy. So the other particles that are in the metal, what will they do? They'll heat up. And that's the reason why, even if photoelectric effect doesn't take place, even if electrons are not coming out, if you touch the metal, what does it feel? Warm. So the energy did go somewhere. It's just that who didn't take the energy? The electron. The electron just didn't want it. Yeah. On the electrons from the heating effect, thermic emission data ওটা হবে, but আমাদের এখানে ওই টেম্পারেচার রিচ করে না। মানে if you could heat it enough that it reaches 5000 volts, তার মানে হচ্ছে 3000 degrees Celsius, তাহলে হচ্ছে emission হবে, but that emission would be a what emission? Thermic, and that's not actually light emitting it. What's emitting it? Heat. It becomes a different experiment. Multiple photons, right? No, so the energy doesn't go to the electrons, it goes to the nucleus, it goes to the atoms entirely. So, you know, when you heat something, right, what heats up? Let's say a table can heat up or down. We say that the internal energy of the table increases, right? What is the internal energy occupied by? Is it the electron or is it the atom as a whole? The atom as a whole, right? And what part of the atom takes the most energy? The nucleus. The electrons are, whether they're there or not there, it doesn't matter, because can you heat up a gas that's an ion? Yes, easily, right? But does the ion have enough electrons? No. So the presence or absence of electrons is not important. It's that the atom's main mass statement. So again, the electrons will gain energy, but they'll give it out again to the surrounding. Okay. Size line. No. It's just imagination. Okay, they're not even sphere. According to Einstein, they're scribbles. That's what he said. Like they're like balls of buzzing things, not like fixed shape. কারণ fixed shape যদি চলে আসে, geometry চলে আসে. Geometry চলে আসলে physics এর change চলে আসে. Like, you know, একটা angle এ hit করতে হবে, একটা curvature থাকতে হবে, এগুলো কিছু নাই. So they're just vibrations, fixed packets of vibration. কারণ energy তো একটা physical quantity না that you can touch. So it's a shape এর কোনো existence নাই. There's no diameter, no nothing. Okay, but strangely they have something, momentum. Okay. So yeah, let's look into this. So you have this photon that comes in, and the photon interacts with your electron. And right now, will emission take place? No. Why is that so? So another energy of my photon is what then the energy needed? Less. And this energy that's needed, it's called phi. And this phi is the new quantity I'm going to teach you. Phi is called work function. What is work function? Work function is the energy that you need to remove the electrons. Okay, so what is work function definition? Carefully, you know, could be easy. It's the minimum amount of energy needed to remove an electron using what effect? Photoelectric effect. So work function kinto not ionization energy. Those who have chemistry, you probably have heard about this thing called the ionization energy. Is the energy needed to remove an electron from where? Gaseous ion, right? Isolated ion. I think you know that the ion is isolated into, but I'm going to take it far from all of those. I'm going to take is it an isolated ion? No, it's like a metallic bond. On top of this, are these electrons on their own, or are they in a separate layer, right? So eventually, I'm going to the work function to remove electrons from here has no similarity to what value? Ionization energy. It's its own value. Okay, so those who don't have chemistry, it's much easier for you. Just understand that এটাকে বের করার জন্য যে এনার্জিটা লাগে ওটাকে আমরা কি ডাকি? Work function. Okay, now for successful emission to take place, can you tell me what's the criteria for a successful emission to take place? Yes, so my energy of photon has to be greater than the work function. Do you agree? So I'm gonna so I'm coming to that. So let's say we use a light here. It I'm going to use green color light, and green color light will emission take place or not? Let's see. So we will use green photons. I have a question for you. Are green photons equally energetic, or more energetic, or less energetic? Yes, very good. More energetic. Why is that so? Right, perfect. So they have higher frequency, and because of higher frequency, these green photons that you see here are actually more energetic, right? So they have more energy. Let's assume that their energy is exactly 15 joules. Do you think emission will take place? barely is not acceptable. Yes or no? No, maybe. Yes. Okay. Because work function is the energy needed to remove it. Work function is not energy maybe needed to remove it, right? So it's the exact value. So the moment you provide the exact value, emission hobe, and this energy will be given to this electron here, and this electron will be emitted. Okay, so emission did take place here. And what's the criteria that we have fulfilled here? The energy of my photon is what to work function? Equal to work function. Okay. Now, this equation won't be complete until we do the final piece of the puzzle, which is what if we use a blue light here? That is what frequency? Much higher frequency, which means the photons here will be what energy? Much higher energy. Do you agree? Okay. Will emission take place here? Definitely. Okay, because our J photon gulo their energy is 20 joule per. So definitely emission hobe. But there's a small issue though. How much did the electron want? 15, right? Aren't you providing extra? And there's the catch. Catch the key, an electron will only undergo what interaction with the photon? 1-to-1. So যদি energy নেয় পুরোটাই নিবে আর যদি না নেয় কোনোটাই নিবে না. It just phases through, right? So এখানে যেটা হচ্ছে I'm giving energy or দরকার 15, but there's some excess, right? And excessটা কার কাছে রয়ে যাবে? Electron. So what happens to it? So turns out if your energy of photon is greater than the work function, not only you have emission take place, the electron that is emitted will have excess energy, and it's in the form of kinetic energy. And we have found that if you keep increasing the frequency of your light, not only electrons come out, they fly out. When they're actually thrown outwards. Why? Because the excess energy becomes what energy of theirs? Kinetic energy, right? So in this scenario, jeta hoy, that the electron will try to emit, but it doesn't really have energy to move out. So এটা মাঝে মাঝে কি হয় reabsorbed হয়ে যায়. So equal যদি work function provide করো, in practical scenarios we don't see emission because the electrons don't really come out to our detector, but they are actually coming out from their structure. Just it doesn't come out to where we are. So আমাদেরকে সবসময় কি energy provide করতে হয়? Little higher. So you can provide energy to the photons so that the electrons so that they can reach your detector. So এগুলা সব মিলে what is the equation that we have? So I'm going to show you the equation. Screen it to দেখো. The equation is energy of photon. How do you frame it? I would prefer to memorize na karo, just buja chesta karo. So energy of photon should be equal to what if emission takes place? Yes, should be equal to my work function. Do you agree? Okay, work function. But what if there's excess? What happens then? Right, the excess becomes kinetic energy here. And that is the equation of the chapter. এখানে একটা ছোট জিনিস অ্যাড করব, might ruin it for you. Max. It can max আমি বুঝাচ্ছি একটু পরে, but that's the formula. Now we're going to do what is convert this into a formula, right? Because এই formula তোমরা জানতে হবে. So what's the formula for energy of a photon? Very good. HF. So HF equals to, what is the symbol for work function? Phi plus what is the kinetic energy here of electron? That'll give a half mass of electron times velocity of electron squared. But this velocity that you see here is what? Max. Why max? Max মানে হচ্ছে এই ইকুয়েশনটা ইউজ করে তুমি যখন velocity বের করো, you'll always find the maximum possible velocity. Why is that? Close. মানে আমি বলি আমরা যদি ম্যাথ করি রিয়েল লাইফে আমরা যে ভ্যালুটা পাবো ফর k, রাইট? আমি যখন অ্যাকচুয়ালি চেক করে দেখবো I'll find the electrons actually have lower k, not the one we anticipated. This is the highest possible value. কিন্তু most of the time it's কম হয় কেন? Where? Electrons air na. Vacuum is same problem as heat. Eventually yes, but okay, close. Yes. Acha, so basically collectively I think you guys are close. So যেটা হচ্ছে electron ধরো এখান থেকে রিলিজ হলো. Where is this electron right now? This one, right at the surface. Or কিন্তু কোনো barrier নাই. It'll just come out from the metal and it'll use all the energy for movement. But imagine a photon made its way all the way down to this electron out here, far beta. There are enough gaps out there. When this electron tries to move out, what did it do? It collide with an electron, collide with an electron, collide with an electron, like a pinball machine, and then came out. As it does that pinball machine thing, right? Does it gain energy or lose energy? Lose energy. So in reality, whenever we find our answer, we find it's always less than anticipated because most of the energy is lost within the metal before the electrons can make their way out. Once in a while, you might find one with which value, this maximum value. And that means that electron was where in your emission process, right at the surface. It had nothing to interact with, okay? And yes, that is the equation for your topic. A equation there, you can solve 80% of the questions you get, okay? HF equals to 5 plus half mv square, which So yeah, I will give you some notes on this if you copy or not, but তার আগে আমাকে বলো if you have any questions. You need any clarification? Okay. আমি হচ্ছে তোমাদেরকে একটা question দিয়ে দিকে. It is actually a very easy topic. It's just that the topic comes out of nowhere. তার জন্য অনেকের জন্য একটু বুঝতে problem হয়. It changes the ideas that you're traditionally used to, but foundation, it's actually a very basic topic. Introductory quantum mechanics. Right, this is the summary. So কি হচ্ছে এখানে দেখো. If the energy of photon is less than work function, no emission takes place. And when I mean no emission takes place, I mean it. And there's no way you can make emission take place. It's not like increase the brightness, throw the photon, whatever you try, it will never happen. Okay, because the energy is just not enough, right? And when emission takes place, you can't stop it. It will happen. Okay, so emission হয়ে ছাড়বে. And once you provide excess energy, emission to হবে, plus the surplus becomes what here? Kinetic energy, right? And therefore you have this equation out there. And yep, so that is it. Copy whatever you want. I'll give you some questions to try. Instantaneous, right? It happens instantly. There's no delay in it. If it was a wave behavior, it would take time. But in this photoelectric effect, if you have the right frequency, the emission happens right away. For that substance at that state. So ice, water, steam, they all have different specific capacity. And the reason is that they have different structure. Specific capacity depends on how energy is transferred within, right? Ice compared to water can transfer energy better. It's a solid. That's the specific capacity for ice is 1950, whereas specific capacity for water is 4200. It's almost double. Why? Water has particles moving around. The transfer is not that good. And when it goes to gases, it's very horrible because the transfer is even worse. So the value is only for states of that matter. ওই substance mean করতেছে ওই state. So ice, water, and steam are like different substances. Which one? No. Phi is the one that's needed to remove its work function. Yeah. Ke max. All right. So our equation here assumes that the electron is where in your surface? At the top, right? So what it means is that the energy that you provide to the electron can completely be used for emission and Ke. But let's say your electron is a little lower. So what will happen is the photon will come and interact with the electron. The electron will try to go out. On its way out, other electrons will repel it. Maybe it will collide with an ion. Maybe it will move around. By the time it goes out, right, it has lost few energy, right? So you'll find that the value of Ke you anticipated is not the real value you get. Why? Because there was some energy loss. But we can't predict that. So our calculation can only predict the amount of energy available for which electron, surface one. And any other electron that you'll find in this setup must have energies of Ke more than this or less than this. Yes, that's what it's called Ke max. এটা কি শেষ? This thing here. Okay, so definition of photon টা লিখে রাখো, very important. Almost every question of quantum physics starts with this definition. What is a photon? Photon is just that, okay? Yeah. Double slit. Left, right, করে যেতে থাকবে, দেখবে স্ক্রিনের মধ্যে ডটস পড়তেছে। No, because the atom পাচ্ছ, atoms তো diffract করা খুব difficult. Electron যদি পাঠাও তখন দেখবে একটা particular speed it turns into what? Wave, right? Right. Yes. So at a particular point cross করলে দেখবে যে the behavior changes. So a point changes the de Broglie wavelength criteria. কোনটা? হ্যাঁ আছে তো, but we তো বলছিলাম যে when we try to see diffract, it doesn't diffract. ওটা তুমি observe করার চেষ্টা করো, an electron will never light হচ্ছে কি লাইট তো সবসময় diffract করবে না, but গ্যাপের ভিতর দিয়ে তো ওয়েভই যাচ্ছে। মানে তুমি I understand your placing metals here, right? But লাইটটা কোন দিক দিয়ে এন্টার করে ডিফ্র্যাক্ট করবে? মাঝখান দিয়ে কিছু নাই। So যখন মাঝখান দিয়ে ওয়েভ যাবে, ওয়েভই তো যাবে, not a particle. If the screen behind is metal, in that case, diffraction pattern, metal screen, we should just see dots because it's a particle photon collider here. Video থাকার কথা দাঁড়া, বলো। Interference pattern gradually হওয়ার কথা না, it has to be at a certain speed, otherwise so every atom will undergo diffraction. They don't. বল কি বলতে চাচ্ছিল? আচ্ছা আমি চেক করে দেখি হ্যাঁ, so they have done it. They have used metal screen, and metal screen হচ্ছে diffraction হয় না. It'll just go as particle. The metal screen is replaced with basic screen, non-metal screen, a dark surface. It becomes like a wave. So it says that the way you interact collapses the wave function, as I just mentioned. So yeah, video to actually, I mean, animation is obviously, but the thing is, video to what are you anticipating to see? Photons. তুমি তো লাইটই দেখবা। It is a particle, তাহলে দেখবা যে there's a streak, and if it's a wave, you see a fringe pattern. So আমরা দেখি যে যখন metal place করা হয়, it's a streak, and once you place a wall, it's a right. আচ্ছা একটা কোয়েশ্চেন করব বিফোর উই র‍্যাপ আপ, বিকজ আমাদের নেক্সট ক্লাসে পরের টপিকটা করব, এখানে I'll show you some questions.
So what is the purpose of light creating beneficial and certain purpose?
In the working of the universe, process to the Kortha information, right? A particle processing would take more information, more energy. So it's better for the universe to keep everything in a wave function. Once you need it to do something, it becomes a particle. So that's what they see. That, you know, when you try to interact with it, when you try to observe it, it becomes a particle. But when it's let alone doing its own thing, it's a wave. It helps the universe conserve energy to a degree. এটা তো যে like computer GPU হচ্ছে যখন কিছু করতেছে না, just keep it as a background, তুমি দেখলে ওটাকে রেন্ডার করে, ওরকম একটা কনসেপ্ট to save RAM. আচ্ছা But have you heard of quantum computer? Yeah, so quantum computer uses wave features to do processing, because particle use for like synthetic, you know, silicon conductor use for, you're using particles to do processing, right? Silicon chip use for. In a quantum computer, you're using waves to do your calculation. And recently at Google computer quantum computing use for it solve the math problem. A math problem যদি normal computer use করে, it would take like 10 to the power 26 years to solve it. It did it in 5 minutes. Willow, right? Right, so a method to borrow, and then we'll wrap up. The lamp has power. Just first part বলে আমাকে চলবে, পরেরটা আমরা next class এ করব. A light source has a wavelength of 400 nanometer. It is shown onto a metal with work function of 1.48 eV. The lamp has a power of 100 watt. Find, does emission take place or not? And if it does, find the maximum velocity of the electrons emitted. This is every question of quantum physics in your syllabus. If you ever solve any paper, you'll find that this is what they ask. So that will power data. So তোমাদেরকে ফার্স্টে বের করতে হবে এমিশন হবে নাকি না, কেমনে বের করবা? Yeah, you're going to find the energy of your photon. এটা কি এর থেকে বেশি নাকি কম দেখবা, যদি বেশি হয় তাহলে হচ্ছে হবে, but not only হবে excess energy টা কিসে convert হবে, so you can find the KE out there, right? So এটা যদি পারো, that means you can solve most of the stuff from this chapter. দেখো পারো নাকি। হ্যাঁ, এই দিচ্ছি, সব দিচ্ছি। These are the constants you need to know. The velocity. So emission takes place. It sounds right. আসে তোমাদের মাইনাস আসে velocity. আচ্ছা দেখতে হবে ধরো। Okay, so that একটা জিনিস বলে নিই আমি, তাহলে তাড়াতাড়ি করতে পারবো। কেউ কি বের করছে was the energy of the photon? How much is it? EV. আচ্ছা, so emission takes place. Do you agree with that? So if emission does take place, তাহলে আমরা directly কোন ফর্মুলাটা ইউজ করতে পারবো? HF is equal to phi plus half mv square. So এখানে আমরা ভ্যালু যদি বসাই 6.63 into 10 to the power minus 34, আমরা এটা ইউজ করি। হ্যাঁ, so hc by lambda equals to phi plus half mv square. So energy value তো তোমরা জানো কত আসছে joules এ। আচ্ছা, okay, so 6.63 but যারা পারো একটু দেখো 6.63 into 10 to the minus 34 into what is speed of light 3 into 10 to the power 8 divided by the wavelength is 400 nanometers, so 400 into 10 to the power minus 9 equals to what is my work function here? 1.48 ev. এটা কিন্তু ev তে রাখতে পারবে না, তোমাকে কিসে করতে হবে এটা কনভার্ট joules এ, right? So 1.48 into 10 1.6 into 10 to the power minus 19 plus half into mass of your electron, which is 9.11 into 10 to the power minus 31 times v square. এটা সলভ করলে যা আসে ওটাই आंसर. So কেউ একটু দেখো, this is like 2 mark, 3 mark, 5 mark in your exam. So প্রথমে 2 mark দিবে হচ্ছে to find the energy of the photon, first part. Second part বলবে hence find the kinetic energy of the particle emitted. কত আসে velocity? So far, I heard 4 different velocities. 7 point into 10 to the power 5. This happens to be the highest velocity you can attain. Okay, typically velocity that you'll find from here is going to be 1 than this, lower. Okay. So yeah, next let's say I'm going to math program and we'll start emission spectrum. So whether Monday class might be just online. Okay, I'll let you know.
Recording stopped.
Not sure yet. I don't. That's what I've heard. Like, delay problem lagi.